Today's lesson is on how do we compare linear and nonlinear functions. A square has side lengths. The table shows the relationship between the side length and the perimeter as the side length increases. The graph shows the relationship between side length and area. How do the two relationships compare? Take a second to copy down the problem with the graph and the table. So when a problem asks us to compare two relationships, there are a number of things we have to look for. The first, we have to see if they are both a function. So if I look at the table, I have 0 going to 0, 1 to 4, 2 to 8, 3 to 12. The side length, which is the x value, does not repeat, so the table is a function. Now I'm going to look at my graph. I do my vertical line test, and I am able to see that no matter what vertical line I draw, it is only going to touch my graph one time. So my graph is also a function. That is the first thing we have to check to see when we're comparing relationships. We see if they are functions. They are both functions. Now I have to determine what type of function each one is. If they're both linear, then I'm going to compare them. If they're both nonlinear, then I can compare them that way. If one is linear and one is nonlinear, then I am not able to compare them. If I look at my graph first, because that's the easiest one to see, this is my graph. I notice that this is not a straight line, so this would be a nonlinear function. Now, I'm going to look at my table. I'm going to see how I'm changing. I am adding by 4 for every single y. For my x values, I'm adding by 1 every single time. So to find my rate of change, 4 divided by 1 is 4. 4 divided by 1 is 4. 4 divided by 1 is 4. So this is a function, and it is also linear. So since I have a linear and a nonlinear function, there's no other way for me to compare them, so that would be the end of the problem. Question 2. Compare the properties of these two linear functions. Function 1 is a table, and function 2 is given to us as an equation. Take a second to copy down this question. So now this problem is a little different. This problem, they tell us that we have two linear functions. So I know they are both going to be linear. So when I know they're both going to be linear, I'm going to compare the slope and the y-intercepts. So I'm going to look at my function 2 first, because that's easier to determine what my slope and my y-intercept is.
Giancarlo, please come to the lobby.
My slope for my equation is going to be 2 over 1, and my y-intercept is going to be -4. Now to find the slope of my table, I'm going to determine how the x values are changing and how the y values are changing. My x value is increasing by 3. My y value is increasing by 4.5. So to find my slope, I am going to do 4.5 divided by 3. 4.5 divided by 3 is equal to 1.5. So my slope is going to be 1 over 5. I know that it's going to be 1 over 5 for all of the tables, all the values in the table, because they tell me it's a linear function. So now I have to determine what my y-intercept is. In a table, the way to determine what your y-intercept is to find the y value when your x is 0. So I'm going to move based off of my slope. So if I move backwards, I'm going to subtract 1 in my x. I'm going to subtract 1.5 in my y. 1 minus 1.5 gives me negative 1/2. I still have to move back one more time, so I'm going to subtract 1 again. That means I'm going to subtract 1.5 again. When I do negative 1/2 minus 1.5, my y value is negative 2. So my b value, or my y-intercept, would be negative 2. Now, I'm just going to compare the two graphs, my two functions. So I can just say function 1 has a smaller slope. It's smaller because my slope for function 1 was 1.5 and my slope for function 2 was 2. So function 1 has a smaller or less slope. And now I have to compare my y-intercepts. So I have negative 4 and I have 2. So I can say that function 1 has a greater y-intercept. And our last question is the joke of the day that we will try to bring back. Why did the 2 4s skip lunch? Everyone try to think of their best answer without looking it up online and come to class with an answer.